Okay, we got to indexers. What is an indexer? Indexer is a way to access elements in a class that represents a list of values. What do I mean by that? Well, let's take a look at a few examples. You have already worked with indexers. Here are a couple of examples. So here we have an array of integers, and this is an indexer. So you can access the first element of an array like this. Or here is a list of integers. And again here, using an indexer, we can access the first element in this list. Now you might say, we already have the concept of lists and arrays and collections, so we are not going to reinvent the wheel. Why do we need to define an indexer in our class? Well, sometimes we have classes that have collection semantics. For example, think of an HTTP cookie. An HTTP cookie, in case you're not familiar with that, is a file that is sent from your browser to the web server upon each request. We web developers use a cookie to identify a user. We can store some settings about the user in that cookie. In that cookie, we have a list of names and values. So imagine in a project we have implemented the concept of HTTP cookie. Now the code that consumes our HTTP cookie class might look something like this. So here we are creating an instance of the HTTP cookie class. We set the expiry date, and here is where we can use an indexer. So with this indexer, I'm specifying that the name of the user is Mosh. Without an indexer, we have to write a method like setItem here and pass a key and a value. You see that achieving the same thing with an indexer is easier and requires less code. If you want to get the value of a cookie item using an indexer, here is what the code would look like. So we simply use the indexer, pass the key, and we get the value. Without an indexer, we have to write a method like getItem. Again, the code that uses indexer is easier and shorter. Now, in real-world projects, it's unlikely that you're going to create an HTTP cookie class because it's already part of .NET Framework. But I use this as an example in case you're working with a class that has the semantic of a list or a collection or a dictionary. That's where you can improve your code by using an indexer. It's not something that you may see every day in your career, but I want you to be aware of this feature. Now, how can we declare an indexer? An indexer is nothing but a property. So we can declare an indexer exactly like how we declare a property. So we have the data type, like string. Then instead of an identifier, we use the this keyword. And here's the indexer notation. So brackets. And inside the bracket, we have the type of indexer. So in this case, with the HTTP cookie, I want to find items by their key, which should be a string. So my indexer here is a string, and I give it a name of key. The rest is exactly like declaring a property. We have a get method and a set method. And here we write the logic for accessing the particular element. Let's start coding and see this in action. Okay, we first start by creating an HTTP cookie class. HTTP cookie. Now I'm going to put this in a separate file. You have already learned that before. Alt and enter, enter. Okay, now we need a field to store the key value pairs in the cookie. The data type or the data structure we use for that is a dictionary. If you're not familiar with a dictionary, it's a data type that resides in system.collections.generic, and it uses a hash table to store data. A hash table has a special mechanism that makes it extremely fast to look up an item by its key. So whenever you have a list of objects and you want to look them up by a key as opposed to an index, you should use a dictionary. If you have a list of objects and you would like to look them up by an index, then a list is a better choice. Okay, now let me declare a dictionary, private dictionary. I want this dictionary to be of type string and string. Now what this means is this is a generic class. This is a generic class, and these are generic parameters. And these parameters specify the type of the dictionary. So in this case, I'm specifying that the keys should be of type string and their values should be also of type string. Okay, now let's give it a name. Dictionary. I would like to initialize this in the constructor. dictionary equals new dictionary. That's it. Just want to recap what we learned earlier. We could potentially go and initialize this field straight here. And that's perfectly fine. It's entirely up to you. You can do it here or in the constructor. Now back here. Okay, now we need an indexer. Declaring an indexer is exactly like a property. So what we're going to do is public. The return type is string because we have key value pairs and they both are string. So string. Now an indexer doesn't have a name. We use the this keyword. So this, and here's the indexer notation. We use string to represent the keys for our key value pairs. So string key. And here inside this property, we have a get and a set method. Now, the implementation is very easy. All we're going to do is to delegate to that dictionary. So for get, we're going to return dictionary of key. So internally, we rely on the dictionary to store the key value pairs. And HTTP cookie is simply a wrapper around that. Now let's implement the set method. Again, very similarly, dictionary of key equals value. And this value is a keyword which represents what is on the right side of the assignment operator. Note this green underline here. That's ReSharper's highlighting feature. So if there are areas in the code that can be improved, ReSharper highlights them with a green underline. In this case, it's saying field can be made read-only. And this is a great example of using read-only because we don't want to accidentally reinitialize that dictionary and lose all the data we stored in it. So here I can just press Alt and Enter and let ReSharper apply the read-only modifier for me. There you go. So as you see with ReSharper, you tend to code less and you can delegate a lot of things to ReSharper. Okay, now this is ready. We can go back to our program. Let's create an instance of our HTTP cookie. Var cookie equals new HTTP cookie. We can store a key value pair using the indexer. So cookie of name equals mosh. So name is the key and mosh is the value. And we can read that from the cookie. So console.writeLine cookie of name. Let's run the application. So the cookie is working. Now let's get back to HTTP cookie class. You might be wondering, why did we create an HTTP cookie as a wrapper around the dictionary? Couldn't we just go ahead and use the dictionary directly? Well, yes and no. In this case, in this simple example, yes, we could definitely just use a dictionary as an HTTP cookie. But an HTTP cookie is more than a dictionary. For example, it can have a property called expiry, and that's the expiry date time for the cookie. So we can go here and create an auto-implemented property for that. So prop, remember that? Tab, that's a code snippet. Date time. Expiry. Our cookie can have other properties or methods. And now it's more than just a dictionary. Internally, it uses a dictionary for data storage. So the takeaway from this lesson is, if you're working with a class that has the semantic of a collection or a list or a dictionary, you can improve your code by declaring an indexer. An indexer is an easier way to access elements in that collection, as opposed to having two methods. Like here, if we didn't have this indexer, we had to create a method like public void set item string key string value. And we also had to create another method like public string get item string key. There's nothing wrong with this approach, but it's more efficient to just use an indexer, both in terms of the code in the class here, as well as the code that we wrote in the consumer here. Okay, that's it for this lecture. I hope you enjoyed it and thank you for watching.